Hello everyone, welcome back to Xenon Circuits. This will be the second lecture on the crash course of basic electronics series. In the first lecture, we looked at finding the equivalent resistance across a given network, where we learnt about finding the equivalent resistance for series and parallel resistor element combinations and also about the Wheatstone bridge concept, right? This lecture will cover one more similar example in finding the equivalent resistance across a given network. Without further delay, let's dive into the lecture. So, the given question is finding R equivalent across between A and B, right? I hope the screen is visible to you guys. So, there has been two nodes, A and B, right? And then there is a network followed by that. So, the first rule which you have learned in the previous lecture is that always look at reducing the the network from the opposite end where your nodes are present. So in our case, we have to find the R equivalent between the nodes A and B. So this is the end from where we are looking the network, but we have to approach by reducing the network from the opposite end, which is this side, right? Let me change the color of my pen. Now you can see that these two resistors 1 ohm and 5 ohm are in series. So the R equivalent between them will be 5 plus 1, which is 6 ohms, right? Now once this is reduced, now I can see there are two elements, 6 ohm and 4 ohm, right? And before reducing this, let's first name the nodes for this network. So this node is B, which means this node is also B, this node is also B, this node is also B. This node is A, but after that there is no short and we have an element, resistor element of 5 ohms, right? So let's name this node as C. Okay, so this node is C, which means this node is also C, but then after that there is a resistor element of 1 ohm. So this will be a new node, which will let me call it as D, right? So between B and D, we have two elements. One is 4 ohm, correct? This is B and this is D. And then the R equivalent between 1 ohm and 5 ohm, which is 6 ohms, right? If we find the R equivalent between 4 ohm and 6 ohms, which are connected in parallel, it will be of 4 into 6 by 4 plus 6, right? Which will be equivalent to 2.4 ohm. Now, we will further draw this circuit, simplify the circuit further. So this is A 5 ohm, and then I have 3 ohm, this is B, and then I have C, then one more C, which has 6 ohm, correct? And then we have a 12 ohm here, and if I just zoom in, right, you can observe that there is an overlap. There is not a short between this 12 ohm resistor and 6 ohm resistor. Rather, this wire is passing on top of this 6 ohm wire. The wire that connects the 12 ohm to the node D is passing on top of the wire that connects the 6 ohm to the node B, right? Let me just zoom back. So what happens is the resistor 12 ohm is connected between the nodes B and D, right? Okay, so this is B, and let me short and take the wire B. Then let me draw 12 ohm. Okay, between C and D we know that we have, let me just erase this for the time being to avoid confusion. Between uh, between C and D, between C and D we have 1 ohm, right? So this 1 ohm is coming over here, and then between B and D we have 12 ohm, and then on top of that the B and D which we reduced, right, between this 4 ohm and 6 ohm, it became 2.4 ohms. So here we have one more resistor in parallel, 2.4 ohms, right? Now let me change the color of my pen. Between B and D we have two resistors in parallel, 12 ohm and 2.4 ohm. If I further reduce that, it will be becoming 12 into 2.4 by 14.4. We know that 12 times 12 is 144, which means this has to be 1.2, right? And then this becomes 1.2 by 2.4 becomes 2 ohms, right? So the R equivalent between 12 ohm and 2.4, these two reduces to 2 ohms. And now if we redraw the circuit, maybe let me just go to the next page. If I redraw the circuit, it will be of, from A we will be having 5 ohms, and then here we will be having 3 ohms at node C, and then this is nothing but node B, right? Node B, and then between B and D we got 2 ohms, and then between C and B we have 6 ohms, right? Between C and B we have 6 ohms, this is also C, and then between C and D we have 1 ohm, and between D and B we found the equivalent resistance is 2 ohms, right? This is also B, this is 2 ohms. Okay, now we can see that the elements 1 ohm and 2 ohm are connected in series. If electron comes from here, it will be passing through 1 ohm and 2 ohm. The same number of electrons will be entering 1 ohm and 2 ohms, right? So these two are in series. So the R equivalent between this and this resistor will become 3 ohm, right? Now the circuit element further simplifies to 5 ohm, 3 ohm, 6 ohm, and then 3 ohm, right? This is A, this is B, these are all B, 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 C, C, C. And just by looking at it, we can say between C and B, we have 3 elements in C parallel, right? And we know that if 3 elements are in parallel, it's 1 by R equivalent equal to 1 by 3 plus 1 by 3 plus 1 by 6. LCM is 6, which means 2 plus 2, 4, 4 plus 1, 5. That will be 5 by 6, 1 by R equivalent. And R equivalent will be equal to 6 by 5, which is equal to 1.2 ohms, right? Okay. Now, if we further simplify this circuit, it will be becoming 5 ohms, and then this is 1.2 ohms. So the R equivalent becomes 6.2 ohms. Okay, R equivalent is, that is RAB becomes 6.2 ohms. So how did we approach in solving this problem? So the first thing which we did was we provided name to all the nodes, and we utilized the node names, existing node names A and B, in order to simplify the circuit and to understand how the elements are connected with respect to each other, whether they are in series or in parallel. That kind of helped us in understanding that this network, though it looks complex, is nothing but a simple network, right? Okay, so we followed the first rule of looking at the opposite end from where we have to reduce. And then the second rule is to name the nodes for simplifying the network, node naming. We did that as well and simplified our network. And then the third rule is just apply the R equivalent and do not commit any silly mistakes, right, while doing the arithmetic operations. We did that as well. I hope you understood how to solve this problem. Let's look into a different problem and learn a different new concept in the next lecture. Thank you.